Okay, I've got a couple more problems on the board, and in just a moment we'll work through them. Before we do that, I want to talk a little bit about the schedule and where we are right now. If you are watching this on the schedule proposed on Canvas, today is Thursday. Oh, you know what? I'm going to write it here. Today is Thursday, April 30th. Okay. So, we're going to have class next Tuesday, which is May 5th. Then on Thursday, May 7th, you've got an exam. Then we have class on Tuesday, May 12th. And you guys got the short stick when it came to final schedule, because on Thursday, May 14th, that's your final exam. So they come pretty close together. Okay, so I just want to make sure everybody's aware of that. So this is going to be the last video for this section, because most of this section is really just putting all the pieces together and reviewing some stuff that we've seen in previous sections. That makes today a little bit short, which is kind of nice because you've got a busy schedule coming up. Okay, so on Tuesday, May 5, we're going to cover section 5.5, which is the last section that we are covering. I will be nice and I will not put that on the exam for next Thursday. Okay, so you can sort of decide if you want to get a head start and go ahead and look at this material now, because we're doing a sort of a short day today. You can do that and you'll be well ahead of the game. If you want to wait because you feel like, oh my goodness, I have so much to study for this exam, and watch this after Thursday's exam, that's totally fine too. But absolutely guaranteed there's going to be a question on the final from this section. So you need to know it by Thursday, May 14. Okay? That is the last section that we're covering, which means we've bought ourselves a day to have a review day on Tuesday, May 12th. Now, I know a while back we did skip a section on exponential functions, but I feel like when you've got the final on Thursday and material on Tuesday, I'd prefer not to do new material on that day so that you can really just focus on reviewing and solidifying what you've gotten all semester. So I will make this day a review day. So I will be emailing the class. You might have already gotten an email by the time you're watching this, or it might be coming, to say if there's anything in particular that you would like to see in a video review for the 12th, let me know. I'll take some requests up to a certain date. What I'm sort of thinking is I might be going over some of the questions from this exam. If people have struggled with particular questions there, I will be posting solutions, but I might do video solutions for some of those as well. And also there's a final exam from a past semester that I post because it's out there. People know students of mine who've taken the class in previous semesters, and sometimes they have access to those. So I try to make it fair. If some people have access to it, I want everybody to, but I didn't ever write solutions to that. So I might go over some of those questions on this particular day. But basically, we're going to finish up with this today. New material on Tuesday that's really important, but that won't be on Thursday's exam. Exam on Thursday, review day the following Tuesday, cumulative final on Thursday, May 14th. Okay, so that's our schedule, that's our game plan for the rest of the semester. All right, enough of that. Let's do some math. So I've got two indefinite integrals up here, and basically they're to remind you of a couple things: what to do when you have multiplication and the difference between these two types of functions. So with that said, I'm going to encourage you to pause the video and work those out, then tune back in and we'll work through them together. Welcome back. Multiplication. We do it. Okay? We don't have a rule for integrating multiplication problems. We will have a rule for certain multiplication problems once we've done 5-5, but only very specific ones. In general, if I've got multiplication that I can do, I want to do it. So I'm going to FOIL this out. I'm going to get 2x cubed. This will be plus 8x minus x squared minus 4. Now at this point, it's a fairly simple problem, but if you forgot to multiply it out first, you can't just integrate that and integrate that. That's not the way integration works. Remember, integration, we're taking the limit of a Riemann sum, so we're doing a bunch of addition. This says multiply first, then add things up in your Riemann sum and take the limit. Okay. So we've got to do that because order of operations makes a huge difference. Okay, so let's see. This will be 2x to the 4th over 4 plus 8x squared over 2 minus x cubed over 3 minus 4x plus c. Don't forget the plus c. And then I'm just going to go back and reduce some of these fractions. So this is going to reduce to x to the 4th over 2 plus 4x squared minus x cubed over 3 minus 4x plus c. All right, for this one, x squared and 2 to the x look so similar because they both have an x, they both have a 2, they both have a base, and they both have an exponent. But this is a power function, so there I'm going to use my power rule. The power rule says if you integrate x to the n dx, you raise the power by 1, divide by the new power, and of course that's providing that that power is not -1, because that would put a 0 in the denominator. The power rule applies when x is in the base and you've got a fixed power. So variable in the base, constant for the power. That's what I have right here. This is an exponential function, and I'm going to need to use my exponential rule. And that's if I integrate b to the x. Well, with exponential functions, if I differentiate them or integrate them, I get that exponential function back. But unless the base is e, I don't get just that. It's modified by a constant. When I take the derivative, I have to multiply by that constant. When I take an antiderivative, I divide by that constant, and that constant is the natural log of the base. Of course, then there's a plus c. Oh my goodness, goodness. I forgot to write my plus c there. Shame. Okay, now I feel better. They both have their plus c's. Okay, but very important to distinguish between those two very different sorts of functions. Okay. So if I evaluate this, power rule here, so that's x cubed over 3. Exponential rule here, so that's 2 to the x over natural log of 2. And then I won't forget it again, my plus c. All right. This is the last section, section 5.4, that will be on the exam next Thursday. Thursday, yes. Thursday's the exam.